Hello, I'm Aaron, and this is my Chapter 2 MCQ test corrections. So for this problem, we're asked to find the force of friction exerted on the block. To find that, we could do sum of the forces. The circle equals ma. The sum of forces, that's friction, equals, it's moving in a circle, so that's mv squared over r. And so when you find the mass, you could do F equals ma, solve for m, and we get the force, and it's 2. And the a, the acceleration, and it's 10 for gravity, we'll get 0.2. We can plug that back into the equation and get 0.2, and velocity, which is 0.6 squared over radius, 0.10. We should end up with 0.72. And the mistake I made was I didn't find m. I just plugged in 2 for this, and I ended up getting 7.2. So for this one, we're asked to find center of mass when it's let go and the acceleration. So when we let go, we know that this one's heavier, so this will go down, and this will cause this to go that way. So that means our center of mass is going like that, so it's down to and to the right. And to find the magnitude of acceleration, we do sum of the forces in the y equals ma. And the force we have is this one, gravity, so it's mg equals ma. And the mass of this is 2m. G equals the mass of the system, just 3m. A, and we're solving for a, so we divide this over, and then cancel out the m's, and we get 2/3 g. And the thing I did wrong, I think I probably swapped these two numbers, and I got 3/2g. And from this one, we're asked to describe the change in magnitude of the sum of forces and compare the coefficient of friction. So we know that our thing is moving faster at B and it's moving slower here. So that means the friction on at A is greater than B. And then for the second part, we're asked to find the sum of the forces on block 2. And we know that the force is equals ma. And since we know that it's moving faster here, that means this is bigger. That means there's more force. And that means the sum of the forces increases when it's here, because the whole system's going faster, and that makes this go faster. So, and the thing I got wrong, I thought when I was going faster, the forces would decrease, so I put A. And for this one, we're asked to describe the length of the spring while it's decelerating. So we know that it's moving constant acceleration, so that means the size of this will stay constant. But we also know that it's decelerating, so it's going up to make it stop moving. And we know that since our thing is moving down or moving up, it needs to be moving down to counteract the gravity, and that means that this one would have to be bigger. So yeah, and I thought that since this was constant, this would also be equal to x1, so that's how I got wrong.